Okay, Mr. Mazer once again with hopefully a shorter video than last time because we don't really have notes to go through. Um, let's take a look real quick and let's see if there is an opener for today. And there is, so here's the opener for today. Pause it if you need to. Says isotope A is an isotope of carbon and has an atomic weight of 14 atomic mass units. Isotope B is also an isotope of carbon and has atomic weight of 12 atomic mass units. Please answer the following. You'll need a periodic table. Okay, pause it now. Try to answer it. All right, now hopefully you paused it and you tried to answer it. Here is how to answer this. Both isotope A and isotope B are isotopes of carbon. And because they're both carbon, they're both going to have the same number of protons. Carbon, if we look at our periodic table, has 6 protons because the atomic number is 6. The number of electrons right now is always equal to the number of protons. So if my number of protons in isotope A was 6 and the number of protons in isotope B was 6, then that also means that the number of electrons was 6 and in isotope A and also in isotope B. So far all the answers have been 6. Where the difference comes in is talking about the number of neutrons. Remember that the atomic mass or atomic weight is equal to the number of protons plus the number of neutrons. So if I know that isotope A has 6 protons from before, and I also know that isotope A has a weight of 14, it basically becomes 6 plus what number is 14. So we got to fill in the blank. 6 plus some number is 14. Sometimes people can just fill in the number and know that it is 8. Or you could do it in reverse and you can just do, okay, 14 minus 6 is equal to whatever the number it is. And that's an 8 in this case. Either way it will work. So 8 is going to go here. Now for isotope B has an atomic weight of 12. So it's 6 plus what number is equal to 12? And the answer is 6. So 6 is going to go over here. Again, if you want to do it the other way, you would go 12 minus 6 is equal to my mystery number. In this case, it was 6. So either way is going to get you to what you want to need, to where you need to go. Okay? Let's look at the worksheet for today that you should have received by now. Looks like this. Asks you some questions. All the questions you can find answers to based on the notes that we took the other day back over here. All these things that we were going through. Okay? And as you go further down, I want you to make your own Bohr model over here. This is the part I wanted to quickly speak to you about. For this, you're filling out for each one of these periodic boxes, what is the atomic number, what's the atomic mass, how many protons, how many neutrons, how many electrons. Let's do one of them together. Okay? Look at your periodic table. I'm not going to flip back and forth because then I'm going to lose all my writing. But look at your periodic table and you should be able to find this out with me. Okay, so we got O. Well, what's O the symbol for? Well, it's the symbol for oxygen. So I'm going to write that in. The atomic number is the number up top. It's that number right there. So the atomic number is 8. The atomic mass is 15.999, so I would round that to 16. The number of protons is also equal to the atomic number, which again is right there. So it's 8. The number of electrons, for right now, is equal to the number of protons. So that's also 8. Eventually that rule will change, but for right now, they're always the same. So the number of protons and the number of electrons right now, always the same number. And then the number of neutrons, remember, is the number of protons plus the number of neutrons is equal to the atomic mass. We're saying that the atomic mass is 16, right? We said that the number of protons is 8. So therefore, filling in the blank, 8 plus some number is 16, that number is 8. So my number of neutrons is 8 as well. I want you to hear me on this because people always get this wrong. The number of protons and the number of electrons for right now are always the same. It just so happened to be that the number of neutrons was the same as well. The number of neutrons does not have to be the same as the number of protons. It can be different, and it often is. And you'll see that as you go through the rest of the examples over here. Okay? So, with that, I wish you good luck. Make sure you're filling out all parts of this. Sometimes people forget that there's blanks in the boxes. Make sure you're filling that out as well. And I will see you next time.